did one problem with the we already did one problem regarding the concave mirror. Can you be more specific? What do you mean by wavelength? Yes, because we did about the problem about the wavelength. I mean, everything we learned that is from chapter 20, 21, and 23. That would be on the test. You already saw. You already saw. Can you please? Uh, okay. Yes. Yes. Wavelength. Everything would be in the test. Yeah. Okay. No problem. So far, so good. So let's continue with our regular lecture today. And I can give you last 5 minutes of today's class just to discuss if you have anything about the test or something like that, right? So right now, let's start with the regular class. What are the chat here? Oh, practice test does not have wavelength formula. Does it? It is not. Okay, I can check it. I can check it. If not, I can replace it with the formula there. But you already saw a problem related to wavelength in the quiz, right? Okay, I'll check it. Thank you for bringing up. I'll check it. Right, if it's missing, then I can replace it with the updated one. Okay, good. And one more thing that I keep on forgetting because there are a lot of things going on. I keep on forgetting uploading the solution of quizzes that you did after the first test, right? Quiz 3 and quiz 4. So I'll do it by tonight, okay? So you have still enough time to go over those solutions. No, you don't have to remember that those will be given. For example, if I give you the problem that has the water and the glass, I'll give you the refractive index of water is this, glass is this. You don't have to memorize anything. Just your name and your Panther ID. Good. Okay. So now let's move to our regular class. So I can now I'm starting the recording again, right? Good. Okay. So what we did so far is that for concave, right? So we defined for concave and we did a problem for concave. So for convex, so just start with the concave here, so just for comparison, right? This is the concave, so that means if the reflecting surface is inside curve inside, this is the concave, right? Then if you draw this is V, and this is this, for example, center of curvature, and this distance is radius of curvature, right? So that means for concave, maybe I did not tell that before. For concave mirror, the center of curvature is always on the same side of incoming rays, right? Incoming rays will come like this, for example, and these will go through the focus, right? So this is incoming ray, this is the center of curvature, right? So if center of curvature lies on the same side of incoming, lies on the same side of the reflecting surface as of incoming rays, right? As the incoming rays, then this is positive. So this is another sign convention. So I can write it for you here. Sign rule for radius of curvature R. Good. Now, uh, if C means center of curvature, if center of curvature C of a reflecting surface or mirror is on the same side of incoming rays, R is positive, otherwise negative. We already defined the sign rule for S and S prime, right? Now this is the sign rule for R and focus F. So that means if you understand this line well, right? Can you tell me what will be the radius of curvature? This radius of curvature for the concave mirror, is it positive or negative? Radius of curvature for this type of concave mirror, this is positive or negative? This is the curved surface. That means if this is the curved surface, center is always towards the curved surface into the, I mean, inside it. So that means center is always this side. Incoming rays are always coming the same side. So that means it has to be positive. That's good, right? You understand? Because center is always into the curved surface. Good. So R is positive for concave. R is positive for a concave mirror. So as F, because F is related to R, because F equals to R over 2, right? Good. So now I already defined the sign rule for the, obviously, any type of curved reflecting surface. So let's move to the convex. For example, we do not do a lot of, again, those definition again for convex because we already knew how to do that. But only let's do the sign rule for convex and do one or two drawing for convex. Okay. Can I erase it? Good. If you want some time, you just can write weight. Since I do not see any weight there, I can erase it. Okay. Okay. So now let's do the convex. So convex mirror is like this. So this is the polished surface is inside. So now this is for convex mirror. So since this is the curved thing, curved part, right? Center of curvature would be here. Somewhere here. You know that, right? So this distance is now radius of curvature. So since this is the curved inward and the reflecting surface is outward, this is the curved surface, this is the reflecting surface, right? So light, so object would be here because the light rays should strike on the reflecting surface like this. For example, I have the object here, right? So the light ray can go like this parallel to the principal axis. So that means now what happened here? The incoming rays are on the same side of center of curvature, or is the center of curvature is same side of the incoming rays or not? Look at very carefully on this mirror, right? No, yes, that's the difference. For concave, right? Since concave, the reflecting surface is also inside, curved inside, and the center of curvature also would be this side, obviously, because this is the curve. So that means if we complete it, the center would be here, right? So for concave, the R is positive. You can clearly see here, for convex, this is convex here. The center of curvature is this side of this reflecting surface. However, incoming rays are opposite. So that means R is negative. We can start from here. R is negative for a convex mirror. So that means, well, why this is important is that when we do this type of problem, or for example, if the question says you, okay, in a convex mirror, right, radius of curvature of the mirror is 20 centimeter. Obviously in the problem it says you 20 centimeter, right? But when you plug in that number in the equation, that has to be negative 20 centimeter. You got it, right? And if you say that you have a concave mirror, then the radius of curvature of a concave mirror is 20 centimeter. Then that number for that concave mirror is positive. Everybody okay with that, right? Good. So far so good. Now, good. So let's see. So let's try to draw the image of this object. What happens here? So this is kind of tricky for convex because it's not as easy as the concave, because in concave you can just draw the reflected ray on the same side. However, this is parallel ray and this is focus here. Focus should be exactly in the middle here. So if I write this is the focus point F, then this is the ray. In case of convex, any ray parallel to the principal axis, obviously it cannot go like this. You cannot draw this ray like that because ray cannot penetrate the mirror. It will be reflected, right? So I can draw it here for concave, just for comparison. So this is concave, this is focus, this is center of curvature. Any ray parallel to the principal axis, when it reflected back, it will go through focus, right? You understand this part. It's easy because reflected back going through focus. However, in case of convex, it will be reflected this side, obviously, because this is the reflecting surface. You understand my point? So light cannot go, penetrate, light cannot refract through that, going through focus. However, you have to draw the reflected ray in such a way that this ray will appear to come from focus. Because this is a parallel, so that means first, the idea, the trick here is that first draw a dotted line like this. From here, draw a dotted line like this that goes to focus. Then draw the reflected ray exactly along this line. Is it good? Maybe not. It has to reflect, obviously. The light has to be reflected like this, but in such a way that now this reflected light appears to come from focus other side. Here the appears is a big word because look here, the reflection should happen here, right? But it follows the simple rule that we define for concave. Any ray parallel to principal axis will be reflected back passing through focus. That is true for concave. Whereas in concave, you can have the real reflected ray going through focus. But in this case, since focus and the center of curvature is other side, right? So these rays cannot go directly, but they can only appear. They will reflect back, obviously, right? Because these two have to be same side. These two have to be same side, incoming and reflected. They have to be same side. But it has to reflect in such a way that it appears to come from focus. You understand now, right, everyone? Good. So this is the one way. Other way, same thing. So if we have any object like this, for example here, then we can what we did for concave, we can have any ray that can strike on V, and it will be reflecting back like this, making same angle, right? So we can do the same thing here for convex also. The same way for convex also. So for convex, or we can have another one, any ray, right? If we have the object beyond center of curvature, any ray passing through C reflects back to C, right? So in this case also, look here, any ray, you can just draw, right? You understand now? You can just draw, everyone, this ray here, one ray that passes through this, right? So that means now this will reflect like this. This angle is theta, this is V, and this will make same angle. This is not same angle, right? Or you can choose any ray that is going through C, and it will be reflected back to C. I can show you later. Now, as I said before, this is the one reflected ray. This is another reflected ray. Now, for the image to form, reflected rays should meet, right? Can you see this? Can this ray and these two rays can meet this side? Can they meet like this? Look here. In case of concave, this is the reflected ray number one, this is reflected ray number two, and these two ray is meeting here, and you will have the image here. You understand? We did that before, right? You are following me. However, this is one reflected ray, this is number second reflected ray. Can these two rays meet this side of the mirror? Is it possible? No, right? So here is the difference. Now, as we said before, if the reflect, look here, if the image or this image, right, image distance is the same side as of the reflected rays or outgoing rays, then the image is real. In this case, this image is the same side of the, like as the reflected rays. These are reflected rays, image is this, they are on the same side of the mirror. But in this case, right, we cannot form image here, they cannot meet here. But what we can do is that in this situation, do you remember what we did for the plane mirror? Yes, exactly. That's what I'm trying to explain. Thank you, Jessica. Now, so now image will appear to form behind the mirror. So since they cannot meet this side, now if you remember what we did for plane mirror, we have to produce. We have to produce these rays. This rays is already being produced. This is already being produced to F. So now we have to produce this ray so that they will meet, they appear to meet behind the mirror. So now look here, I'm producing this ray. Producing means I cannot bend. I'm producing this ray. Now these two produced rays, they are not real reflected rays. Now these two produced rays meet here. So that means now, since this is the intersection point, the head will form there. So obviously now this is the image. I'm raising this just to make sure that we don't have much clutter here. So now this is the image here. Look, image is formed behind the mirror. So that means clearly this image distance here, I can write it. This is S prime. So clearly what you can see here is that the image distance is negative, right? Because the image is not on the same side of the reflecting surface as the reflected rays. Image is on the opposite side. So that means, look at difference here. So that means this image distance is negative and the object is virtual, obviously, right? If the image distance is negative, object is virtual. If the image distance is positive, object is real. Here, this S prime here, we did that before. This is S prime. Since S prime is positive, for positive S prime, image is real. For negative S prime, image is virtual. Valid is fine. You understand now? I explained your question. Good. Now here comes the important point. Compare. Compare these two. Okay. S prime negative, image is virtual. One thing that you can contrast. S prime positive, image is real. So that means if S prime is positive, image is real. If S prime is negative, image is virtual. So we can make a note of that. So that means in this case, S prime is negative. That gives you virtual image, right? So we already defined for this. In this case, S prime is positive. That gives you real image. So just for comparison, right? So just write, fill in this first, and then we can fill in this side later. You understand, right? Do you see any difference between this real image and this virtual image? One is the one difference is I already saw it, tell you. This is positive, this is negative. Other than that, do you see any other difference actually on the image itself, about the image itself? Is there any difference? So virtual equals to image in the mirror. Yes, no, there are, okay, not on the focus. The focus, this is also not on the focus, by the way, do not get confused. This, they are not meeting on the focus, they are meeting here, right? So one is this, the other difference is that clearly this image is inverted. See here, this image is inverted, this image is right upright. You understand now, everyone? This is upright. So you have this, look here, this is top. See here, this is top. You have placed this like this, top like this, and this is same, and this appears same as that, because the light rays, I mean, they are meeting here. At the meeting point, we always draw head, and other point is the foot, right? So this is head, this is foot. So that means this image is upright, and this image is hanging. This is head, this is foot. So that means this image is inverted. Everyone okay with that? So that means this is always true. Real image is always inverted. Virtual image is always upright. Good. So that means in this case, so for the virtual image, right? Again, image is upright. Good. Yes. One thing is that you are right. This is smaller, but not all virtual images are smaller. Only the virtual image, the virtual image produced by convex mirror is smaller. In some cases, concave mirror can also produce virtual image. Only in one case, I'll show you later. And that virtual image is larger than the object. So that's the distinction between the virtual image produced by concave and convex. Convex mirror always produces virtual image. Not only in convex. All virtual images are upright. Even though it is produced, even in the case the virtual image produced by concave, all the virtual images are upright. All the virtual image S prime is negative. This is true for any type of virtual image, right? So this column is for virtual image. So if I want to write for real image, right? So again, as I said before, concave mirror can also produce real image in one situation. I'll tell you, I'll show you later, right? But these two conditions are always true for a virtual image. It doesn't matter whether it is produced by convex mirror or concave mirror. Convex mirror always produces virtual image. You understand my point? And concave mirror can produce virtual image only in one condition, and I'll show you later. Concave mirror mostly produces real image, but in one situation it will produce for virtual image, and I'll show you that later. But no matter which mirror is producing virtual image, these two are always true. You understand my point? Good. Okay. And in the next part, I'll show the contrasting between the virtual images produced by convex and concave. Okay. For real image, S prime is positive. That is, this is, and the image is inverted. These two are always true. These 2 points, this is for virtual. Right? Please make a note of these things, okay? Yes. Now, these are always true. Now, what I'm doing is that I have this here. Now, I just do this here for you. I can just erase this, and I just draw an image for this, for the concave, okay? Now, this is my concave mirror. I don't have very, okay, so what should I do? Okay, I should draw here. You're already done with this. I think it is better to draw below here, okay? Good. Now, let's draw the concave again here. Okay, now I have the concave mirror here. So I have the center of curvature here, and I have the focal point here, right? So now, usually this is called the ray diagram, right? Or finding the position of the image using the geometry, right? So in this case, when we draw a ray diagram, we know that any ray parallel to principal axis reflects back at focus or appears to come from focus in this case. Any ray passing through focus, it reflects parallel to the principal axis. I wrote that before. Any ray going through center of curvature will be tracing back following the same path, right? We know that, right? And any ray that strikes in the vertex will be reflecting back following the law of reflection or symmetrically. So let's see here. In case of concave mirror, if you put if you put the object here, beyond the focus, image is always produced this side and always real, right? And always inverted. For example, I'm just doing this, okay, for concave. If you put the object here, so usually we only need 2 rays to form the image, and it is always easier to have one ray that is parallel, that comes through the focus, and to have other ray that goes through vertex and makes same angle. Or if the object is beyond center of curvature, you can take that through the center of curvature and it comes back also, right? We can do that. Okay, let's take the one ray that is parallel, right? Okay, draw yourself. When this is reflect back, draw yourself first. I'll give you some seconds. Draw yourself how it will be reflected, and then I'll draw. Okay, you'll have 20 seconds. Starts now.
¿Dejaron afuera? No, el hummus.
Yes, it reflects back through the focus, okay? Let's do this. I hope that you already did this. So any ray parallel to the principal axis will be reflect back passing through focus.
Yeah. Oh no, I did it wrong.
Can you mute your mic, please? Okay, this is reflected rays, okay? Good. So now, at least we need 2 rays to form the image, obviously, because we need that point. You can draw one ray that goes through this point that will be reflected symmetrically, or you can just draw another ray that goes through C and it will reflect back through C. You understand my point? Or you can draw three. Good. So let's do this. Since we have C, then we can draw the line going through C. Okay, I just use the other color for this. I have red color here. You can do whatever way you want, or you can do three of those, right? It doesn't matter. So if I draw any line that goes through center of curvature, right? So obviously it will be reflected back. This is the incident, this is reflected. So that means same line, so they will meet here. So that means image will form there, right? You understand my point? So that means at least we need two. So this is image, and image would be always where the light meet. We have head there, and we have foot here. So that means this is image point, this is object point. Or you can see here, if you draw another ray that strikes here, it will come back exactly meeting same point. You can draw that. You can have three rays, it doesn't matter. You can have, at least you need to have two, right? You understand what I'm saying? If you have number of colors, you got it, right? If you have number of colors, you can draw one line like this. I can show you, but it makes my image messy that I can, okay, I'll just erase that later. If you draw a line that incident here, it will reflect back and pass through that point. You understand my point? So all three will meet there. So we don't need three rays, right? We need at least two rays. So it's up to us which we choose for two, at least two rays, right? Okay. So now, when the object is placed beyond the center of curvature, now you see the image is inverted, and this is positive S prime. This is S prime because this forms on the same side. So that means the image is real, right? Image is real, inverted, and this is smaller. You can easily see that. And obviously, because this is S prime. S prime is obviously smaller than S, and magnification would be negative S prime divided by S, and obviously this is less than 1, right? You can see that. If you see here, the magnification equation would be H primed over H, that is equals to S primed over S. If you see here, from here to there is S, from here to there is S prime. Obviously, S prime is smaller than S. The magnification would be smaller than 1. So image would be smaller than object, right? You understand this part. Okay, so how do we define the sign convention V4? Okay, what is this? From here to there, this is S prime, right? And this is S. So if S prime is positive, image is real. I just defined that in the previous when I erased it, right? If S prime is negative, the image is positive, the image is real. So can you tell me this S prime is positive or negative looking here? Using our sign convention that we already defined. What about this S prime? It is real or it is positive? So it is positive means go back and check slightly above in your note. We clearly write that S prime is positive, image is real, and real image is inverted. S prime is negative, image is virtual, and virtual image is upright. I just wrote that, right? You understand now? Okay. So that means this is S prime. So again, so the whole point here is that now you don't have to look at the S prime and check for the negative or positive. You can just look at the object now, because we know that if the object is inverted, image, if the image is inverted, and that is real image. And obviously, if you look at the sign convention, you will find that S prime is also negative, positive. Everybody okay with that, right? Now, easy trick. Just directly looking at the figure, easy trick is that looking at the image. If the image is hanging or it is inverted, then that is real. If the image is upright, that is virtual. Got it? Everyone is okay up so far, right? Good, good. Now, so what I'm speaking is that since this is object height, this is image, you can see that obviously this is the I mean diminished. Okay, let's do a few more example here. Everyone, what I suggest to you is that I will erase it here because I didn't have any more space, right? I erase this and I put the object somewhere other place and we draw it again. But in your notebook, I suggest you to draw entirely new image, okay? New drawing. You understand? Good. So now let's place the object. Let's place the object somewhere here in between C and F. Can I erase this now? Can I erase this only the erase? Okay, everyone? Okay, good. Now I'm erasing this. Good, good, good. Okay. Uh-oh. This one here. I have C and F here. This is C, this is F. Okay. So let's put the object here, somewhere here. Right? So this is our object. So now it's always easier to draw an array. It is always easier to draw a ray parallel to principal axis. So let's draw this. And then obviously this will get reflected back through focus. You draw it. So this is the reflected ray. So now since we do not have center of curvature for this object, obviously, so we cannot draw. So we can draw either one ray passing through V or other ray that goes through focus. If I draw this ray that goes through focus, it will reflect it back parallelly, right? Since previous example we did the ray passing through vertex. So in this case, I would like to draw this ray that goes through focus like this. What happens with this ray? The ray that goes through the focus will be reflected back parallelly, right? We know that. I defined that earlier. So this is here. So this ray will go like this. So the image will be formed somewhere here beyond the center of curvature. Again, as you see here, this is the same side. This is the same side as of the incoming rays, right? So this is again the inverted, obviously you can see that, and this is the real, right? So this is S prime. So S prime is positive, so it is real again, right? This is again real image, right? Previous also real image. You can write that in the previous image, right? Good. Okay. Let's see what happens when the object exactly at the focus. I'll give you a few moments to finish this. Then I have erased it. You guys are done. Can I erase it now? Okay. Okay, so if I have the object exactly on the focus, like this, so again, any ray that is parallel to principal axis will reflect it back through focus. Right? So we don't have, so we cannot draw any rays through C or through focus because object is at the focus. So we have to draw this ray here. This strikes at vertex at this angle, sorry. And this has to reflect back, making same angle like this. So in this case, if you look this, these two are parallel. So when you place the object on the focus, the reflected rays will be parallel, right? So they will not meet here, but the parallel means they can meet at infinity. We say that to infinity. So that means image will be formed at infinity, right? If the object is exactly at the focus. So if we have the concave mirror and you put the object exactly on its focus, right, the image will be formed very, very far at infinity. So you may have the good idea now. Now, when is it at focus, it image is formed at infinity. So if we, what will happen if we even push the image further close to mirror, right? So that means we already reached the limit point here. We already reached the limit point. So that means when the object is at focus, image will be formed at infinity. Then if I even push this image further close to the mirror, then the image will not form the same side. In that case, image will form other side as this mirror, and that would be the virtual image. Good. Let's try to do this. So now, if you do that, then I can erase it and show that here for you. Good. Okay. Okay. So now, if our object is somewhere here, somewhere in between focus and the mirror, then we can always draw a ray parallel to the principal axis. So this ray will pass through focus. Right? Now, we can only draw a ray that strikes here, and then this will be reflected back, making same angle like this. And then if you see here, they cannot meet this side, right? However, if you produce, as we did before, look here, they cannot meet same side, right? Look here, they are diverging. They cannot meet this side. So now you need to produce this. You need to produce this. So they will meet somewhere here. So this will be the head, this will be the foot. You got it now? It's not very good because this is bending here. I don't know why I draw this way. Like this. Yes. So what does this mean? If the object is placed, somewhere between focus and the mirror, look, these rays cannot meet this side. So that means now this is S prime here, right? So in this case, S prime is negative as this. Look, other side of the incoming rays. So this is negative, and you can see the image is like a upright. So that means this is negative. So now this is virtual. This is virtual image. So look here. So as I explained to you, concave mirror, in most of the situations, concave mirror will form the real image, right? And the real image formed by concave mirror may be smaller than object or larger than object, depending on where you put the object. Real image formed by concave mirror may be smaller or larger than the object. However, if you see this, if the object is placed, right? If the object is placed anywhere in between focus and the mirror, then image is virtual. Concave mirror can form virtual image when the object is placed in between, anywhere in between focus and the mirror. The virtual, look here, the virtual image formed by the concave mirror is always larger than the object. That always happens. If you see here, this image here is larger than the object. So again, does the same apply for the convex side? No, that's what we're saying. Convex, in case of convex mirror, look, I'm saying, convex mirror always forms virtual image. Convex mirror always forms virtual image, no matter where you put the object. You understand my point, right? No matter where you put the object, convex mirror always forms the virtual image. Got it? And the virtual image formed by convex mirror is always smaller than the object. Virtual image formed by convex mirror is always smaller than the object. So that's the very important point to distinguish between the virtual image formed by convex mirror and the concave. Okay. Virtual image in one condition when the object is placed anywhere between focus and the mirror, right? However, the virtual image formed by concave mirror is always larger than the object. That's the distinction. So if you have, for example, if I give you a problem like this, you used a mirror to form a virtual image of an object, right? You use a mirror to form a virtual image of an object. The image is virtual image which is larger than the object. You understand my point? You use a mirror to form a virtual image which is larger than the object. Then if I ask you what is that mirror, then what is that mirror? Yes, concave, right? So that's how we distinguish. Yes. So concave mirror in one condition only forms the virtual image, and when it forms the virtual image, that virtual image is always larger than the object. And convex mirror always forms the virtual image, and the virtual image formed by convex mirror is always smaller than the object. You understand now, right? So far so good. Okay. So now you can write this line here, right? Convex mirror always forms virtual image, right? And then virtual image is always smaller than the object. I can erase this. The virtual image is always smaller than the object. Good. Similarly, concave mirror forms virtual image in only one condition, that is when the object is placed anywhere between focus and the mirror. I can erase this part, right? Okay. Second, concave mirror mostly forms real image except when the object is placed somewhere between F and V, or focus and mirror, right? You understand this part, right? And this virtual image, and the virtual image is always larger than the object. So now this is the way that how we distinguish between the virtual image formed by convex mirror and concave mirror. Good. These are very important concepts that we learned today, right? So again, this chapter is not. I mean, you will not see this chapter in the test. So right, we will continue with this from Wednesday again. Monday we have test. Right now, I'm just stopping the recording now. So I thought that I'd give you some. Yes, yes. This chapter, current chapter is for the next test. Again, test is still from chapter 21, 22, and sorry, 20, 21, and 23. I already emailed you about this, right? Chapter 20, 21. We didn't do 22. Final would be cumulative. Again, final would be cumulative, but you know that how we do cumulative, right? It will not be all cumulative, but again, I'll give you the topics for cumulative, and then final would be cumulative among those topics that I give you. Good. And we can discuss final later. I cannot tell you that would practicing the quizzes posted and the practice exam be enough practice for the exam. Again, as I said before, exam would be similar level of the quizzes, right? So that means, yeah, you can expect the problem of the similar level of the quiz. And if you only do those problems, that may not be enough. But for more practice, I still suggest you to do the homework or practice problems that is available. Yes, I said you, I put that in the email also. If nothing had changed, the test is still from the same chapters that we told last time, right? Only thing that changed is that we are doing chapter 24 and chapter 24. 22, we did not do chapter 22. Test would be from chapter 20, 21, and 23. Okay, please refer my last email that I sent you maybe on last week, Thursday or Wednesday about the test, right? If you still have some confusion, I can send another email also, but please keep track of what we communicate in the canvas. Okay, those are important communications. Yes, I can do that. The thing is that I've been getting us emails about that. Again, if you cannot cover everything, at least I would like you cover the workplace. That would be fine. Some part of the screen or workplace needs to be there, right? What you are working, what you are writing on the scratch paper. If you can if you can have that view in Zoom, that will be fine. You don't have to have your face or your workplace and computer together, right? If you cannot cover everything, at least I expect you to cover the workplace. That works, right? You and everyone, right? So at least on your table. Yes, exactly. So if you cannot cover everything, I understand sometimes it is difficult to cover everything, right? So at least you just focus on the work area. That if I want, I could see that the your work area without dropping it means what? Dropping internet or dropping the phone? Oh, no, you don't have to do that way. I mean, you can just put the phone some kind of elevation if you could find, right? And then put that phone constantly there. Oh, that's the good point. Yes, yes. Let me think. Wouldn't the people see your work? Yeah. Mm, So everybody can see everybody's work. Here is a very good question brought up, because if your camera focuses on the work, then other people can see your work. It's mm, kind of yeah. I mean, you brought up very good point, because every participant can see the video of other participant, right? Mm, yeah, it's a kind of yeah, difficult to do so. Uh, yeah, yeah, you're right. So I think let me think about this, because again, some of you voiced the concern about a webcam. That's why I need to do this kind of things. Otherwise, universities recommended us to use the honor lock, right? And honor lock is free, and they are strongly suggesting the faculty to use honor lock. And some of you voiced against the having the web, and some of you voiced that you don't have the webcam with you. So that's why I could not ask you guys to buy the webcam at this moment. But again, I told you that we have to go with the honor lock during the final. There is no way other than that, right? So let me think what we can do. Yeah, I understand. You have a valid concern. Exactly. You brought up this, and I really like that. If you focus the camera on the workplace, other people can obviously will see that, right? So that's a very valid point. And actually, being frank, I haven't thought that way, and it's a very, very, very valid concern, right? So let me think. And as Jessica suggested, let's meet maybe tomorrow again to discuss about this, everyone, right? If you have time. So let's meet tomorrow, and just like I'll come up with some idea, maybe not focusing on the workplace, maybe focusing on your just focusing on the computer only, or something like that. Okay, I'll come up. So I just need to do this to follow the protocol. You understand my point, right? So uh, I'm trying to do my best, just following the protocol, and just to make things not very hard to you guys. You understand, because I'm in very difficult position right now, right? So I mean, you understand that position, right? Because this is online. So that means I'm trying to do I mean, I'm trying to do best as possible. So whatever comes in best, then we could do that. Okay. So okay, I'm yes, that may be fine. That's what I'm thinking. How about having the phone on some plane as paper to see us? So I just want to make sure that the work cannot be seen, because if you are focusing on the work, then other people can see your work, right? So yes. So this is kind of difficult situation. So I'm trying to do something. So we can we can meet tomorrow around maybe kind of late afternoon, if it's fine, maybe around 4 or so, right? Yeah. So I'll just create a Zoom meeting and then send an email. Okay, good. So see you tomorrow. Okay, good. Bye bye. And again, take care and see you tomorrow. Bye.